Alright, you're welcome once again to this channel. And in this particular channel today, we'll be looking at that of differentiation, elective mathematics. In differentiation, I'm going to make it very simple for you as usual. So we'll look at the rules of differentiation. If you look at the rules of differentiation, the trick you have to know for able to look at the rules, instead of taking the rules one by one, remember this one: power down, PD, P minus 1. Look at it. If you remember this, that makes the rule easy for you. PD P minus 1. What do I mean by PD P minus 1? Now, P here means power down, power down, power down. What's the PD? Power down, power minus 1, power minus 1, power minus 1. So, if you remember this, it makes it very, very simple for you. Don't forget to subscribe. Don't forget to like this video as you move on to study here. Now, so let's take an example and see what I mean by the PD P minus 1. Good. Basically, if they give you PD P minus 1, we are looking at, for example, they're giving a question like 5s cubed, y equal to 5s cubed. You have to differentiate this one. Differentiate this one, it will tell you to find the y, the x. You are differentiating this one. So, the power here, power down, power minus 1. So what's the power here? This is the power. So power down. So that is going to give you 3. Then you're having what? 5x. Then you see power minus 1. If you subtract 1 from the power here, which is 3, what will you get? You are going to get 2. So the answer here is going to give us, you see, power down. This is the power down. Power minus 1. That's 2 here. So you are going to get 15x squared. So basically, this is a principle that I would like you to take. This is a mnemonic I would like you to take before we move on. Power down, power minus 1. So let's quickly move on to more of the differentiation and see how we can differentiate other numbers as well. So as I said, we are having power down. Don't forget power down, power minus 1. That's the mnemonic or the trick you have to use here. Now, before we're able to look at the power, let's look at how to make exponent of some expressions before we look at the rule. Start using the rule. So if we have maybe x, square root of x. Now let's put it in the power form. What will it be? It's the same as what? X raised to the power 1 over 2. If you have something like this, cube root of x, this is going to give you what? X raised to the power 1 over 3. If you're having, let's say, cube root of x raised to the power 4. Now the rule is that the inside one should be at the top. So this is going to give us x now. The 4 is at the top, so it's going to give 4 over 3. What if you have, let's say, you have a number like this, x raised to the power 2. It's going to give you, the 2 should be at the top, so it's going to give you x 2 over 5. Obviously, let's know how to express this before we move on to the rule. Now, if you're able to express this one too, there's one thing again you have to know. What if this particular number, we have 1 over square root of x? Now, we can change this one. We know this is the same as what? 1 over what? X. Square root of this one, as we know here, is the same as half. But because there is 1 at the top, at the top, what you're going to do is that you make inverse of it. To make inverse of it, it's going to give you x now. To remove the 1 here, minus 1 over 2. Just the inverse of this gives you negative. So if I have, let's say, 1 over x raised to the power 3 over 2, you can rewrite it as what? X raised to the power minus 3 over 2. Similar here, if you're having 1 over x raised to the power 4 over 3, you can also be written as what? X raised to the power minus 4 over 3, because of the inverse here. Is that okay? Let me give another. What if you have, let's say, 1 over this same number, x raised to the power 2 over 5. You have to rewrite it in linear form here, so that you have it as what? X raised to the power minus 2 over 5. Now we know how to express this in power form and this. So what if you are given a question like, you have a variable like, here I'm not differentiating, you are just looking at how to express in the power form. But if you have a number, let's say 2 over x raised to the power 3 over 4. this particular number, I can rewrite this as 2. Let's say the 2 is already here. Now, if I bring 2 here, you know this is going to be like, if I shift the 2 here, it's going to be like, this is going to be like 1 over this. So I'm going to write it as x minus 3 over 4. Well, how do I get this one? Look at this particular number. If you're having 2 here can also be written as 1 over x 3 over 4. I hope you agree with me that this ain't here. So I told you anytime you have 1 over any number, the same as the inverse of it. That's why I'm writing 2 here. And the inverse of this one is going to give you inverse of it, going to give the negative value. So x minus 3 over 4. Know this one very well, then differentiating very easy for you. If I have a number like 3 over, let's say x is number 3 over, let's say 4 over 3. 4 over 3. This can also be written as what? You know that 3 here is inverse. This x, what you are going to differentiate is under is the denominator. Because the denominator make it linear. So if this is a denominator here, I write a 3 here. And then the inverse. So it means since I shifted a 3, this is going to be the inverse. So I'm going to write it as what? X minus 4 over 3. Now that you know you are familiar with this one, let's now move on to the rules of differentiation and see how we can use it and apply it. So quickly, as we said, looking at that, let's look at how to differentiate a constant. We are differentiating a constant. It's 0. So example. So let's look at this one. I know y equal to this. We have y equal to 5x squared here. What's the rule here? The rule says that to differentiate this one, you're going to find dy dx. It means I'm differentiating it. And so we said power down. So that's power down, which is what? 5x. Then power minus 1. So 2 minus 1 will give you 2 minus 1, right? You don't need to write this one, but let's just go. That's going to give you 5x, right? So the answer is going to give you 10x. Now you realize that so you are saying, assuming you're differentiating a constant, like for example, y equal to, you have y equal to 5, and I have to differentiate this one. You remember there's nothing here, so it's just going to be 0. There is no x here. So if I want to introduce x to this one, I can write x raised to the power 0. You know, any number raised to the power 0 is 1. So this thing is the same as what? 5. The moment I wrote x and I put 0 here, it's the same as 5. It didn't change the question. So because we know any number raised to the power 0 is 1. So if I'm differentiating this one, power down, right? So dy dx, power down. So if the power down is here, so that's going to be 0, 5x. 0 minus 1 give you minus 1. But we know 0 times a number is going to be 0. That's how come we are saying anytime you're differentiating a constant, that's the first you should know. Anytime you're differentiating a constant is 0. So if I give you y equal to 5, y equal to 6, because a constant, dy dx will give you 0. Assuming you have y equal to 9, you have to differentiate this one because there is no variable to differentiate here. It's a constant. 9 is a constant. The number is a constant. So dy dx will give you 0 because it's a constant. Now that's the first you want to know. What if you have a linear? Let's say it give you a question y equal to 5x. Now there's a variable here. So to find dy dx, the rule power down, power minus 1. Don't forget this trick. Power down, power minus 1. So 5x has a power 1. So power down going to give us 1, then 5x. 1 minus 1 will give you 1. Minus 1 will give you 1. You don't need to write all this, but for a beginner, let's look at it. That's going to give you 1 minus 1 is going to give 5 raised to the power x0, which is going to give you 5. So in short, if you have, so you see, anytime differentiating only the variable with that exponent, it is just 5. For example, if they give you a question like y equal to 9x, if I have to differentiate it, dy dx, just write, forget the 9 because it's only power 1, it becomes 9. I told you how can we have that one. If I have a question like y equal to 8x, because it's only, you are looking at only what the a is constant. The a is constant. Because the a is a constant, this is a constant, and just one variable here. We're going to say dy dx is equal to just 8. But don't forget, we said if it's y equal to 8, dy dx gives you 0. But here there is a variable that we are going to differentiate. And what we did, how can we have the 8? We said if we have, how can we have the 8? We said if y equals to 8x, we know the power here is 1. So we said dy dx, power down, power minus 1. So I bring 1 here, which is 8. I multiply, then x, 1 minus 1 will give you 0. So in number with the power 0 gives you 1. In number with the power 0 give 1. So we're going to have 1 times 8, which is going to give you 8. That's what we said. So those are the basic rules now. Let's now move on to when we have other numbers, when they are adding the sum. Alright, so let's say for instance, you are given a question, you have to find if y is equal to, let's say, 2 over x cubed. you have to find the y, the x. So to differentiate this one, first of all, you see the power here is down, the number here is the denominator. What I'm differentiating here is the denominator, so I'll make it linear. That's the first thing I'll do. So I have y equal to 2 here. I told you this one is like the inverse, right? So we're going to give our x minus 3. How did I get this one? Let me tell you how can I have this one. This is the same as 2 times 1 over s cubed. Have you seen it? And we said if you have 1 over s cubed here, the same as the inverse. That's what I've written here. So now that it's linear now that what you are going to differentiate is not a denominator, we cannot find the dy, the x. So dy, the x here, we are going to have now, we say power down. So that's going to give you power down minus 3, then 2x. Power minus 1 going to give you minus 3 minus 1. So minus 3 minus 1, as we said, power down, power minus 1. Don't forget the trick. So I'm going to get what? Minus what? 6x here. Then here we're going to give you what? Minus 4. Minus 4. So this is it. So now we can now, so this is the y, the x. So this can also be rewritten as what? We want to take it backwards. So this answer is correct. This answer is correct, but we want to take it back to the denominator. You're going to get, if you're going to take the denominator, don't forget, this is the only thing, it's only the x that you are taking to the denominator. So it's only this one that if I want to take the denominator, only this one, right? So I can rewrite this as what? Minus 6. Then if I take it to the denominator, it will now become positive. You remember it was, so from to the denominator is going to give you x power 4 here, because this negative I take to the denominator becomes power 4. So those are some examples of solving this with. Now what if I have a question like y is equal to 1 over x power 4? So to differentiate this one, I'll make sure that the difficult I differentiate this is a denominator, make it linear. So this is the same as y is equal to x minus 4. Now that it's not a denominator now, I cannot differentiate it. So the y now, the x is going to give you power down, so minus 4, power minus 1, that's going to give you power minus 1, going to give you minus 4 minus 1, it's going to give you minus 5. So I can take this one back to the denominator, only this one, not the whole number, only this one. So I'm going to get minus 4, then x raised to the power 5. And that's going to be your answer for this one too. Good. What if you have a question like y is equal to 3 square root x? Now this one I want to rewrite it. So this is going to give me y equal to 3. Then I'm going to have this one, I want to have the power for it, power. So square root of x is the same as what? X raised to the power 1 over 2. So you differentiate this one quickly. You see that if you differentiate this one, now what they are going to have power down. So power down here. So power down. So that's going to give me half power down. Then power minus 1. Half minus 1 is going to give you minus half. Minus half. Right? So if you multiply this one 3 times, this is going to give you 3 over 2. It's going to give you 3 over 2. If I multiply this one, that's going to give me 3 over 2. Sorry. You're going to get 3 over 2 here. 3 over 2. Then the power here is going to give us. So what are you going to get? 3 over 2. Then x raised to the power minus half, right? But if we multiply this one, I'm going to get 3 over 2. So this can also be written as what? Now we can take this one back. So 3 over 2 times what? Let's take this one backwards. So it's going to give us what? Square root of what? The same as this can. Minus half can also be written as what? It can also be written as 1 over what? Square root of what? X. Have you seen it? So let's look at more examples and familiarize ourselves with it. Okay, so let me teach you this before we move on. If I have x raised to the power 1 over 2, we know it's the same as what? X raised to the power or square root of x, right? If you have a number like, let's say x raised to the power, let's say 3 over 4. If you want to put in a form, square root form, remember this is going to give you x here, square root. The top one is always inside. That if you want to take it backwards, the top one should be inside, and then this one should be power for this thing. So if I have maybe x raised to the power, let's say 4 over 3, this is going to give you, if you want to put in a square root form, then the 4 here, the top one should be at the inside, top one inside. Then the denominator here should be what? The cube root. So that's how we write it. Is that okay? Don't forget that one. Quickly, let's look at how to. So let's look at some example and see how you can solve it. For example, if you have a question like y is equal to 1 over, let's say, cube root of x raised to the power 4. Now we have to find the y, the x here. I told you, because this, what you are going to differentiate is, now let's make linear before we even start the differentiation. So this is going to give you 1 over what? In fraction form. I told you x here, the top one should be at the top, so 4 over 3. It's still denominator, so why don't we make it linear? So it's going to give us x, I'm going to bring the top, minus what? 4 over 3. Now that it's linear, now we can now differentiate it. So let's differentiate it. We can now find the dy, the x of this number, dy, the x. So what are we going to get? I'll bring the, we say power down, power minus 1. So what's the power here? Power down is what? Minus 4 over 3. Power minus 1. So minus 4 over 3 minus 1. What is going to give you? Minus 4. That's going to give you minus 7 over 3. So if you subtract 1 for power down, minus 7. Minus 4 times 1 give you minus 4. Then here we are going to have 3. Then we have what? The cube root of what? Cube root, this one, cube root, this cube root of what? X raised to the power 7. And that's going to be your answer for dy dx. Very, very simple. So these are the basic things you ought to know. What if you are given a question where now they are adding it for you, you are summing it? If they are summing it, don't worry, it's just the same thing. So we are looking at differentiation or sum or difference. So let's say, for example, you have a question like 3x squared plus 4x. If y equals to 3x squared plus 4x, you have to differentiate this one. Just find the y dx. Here you take them one by one. You just do it one by one, and that's it. So I'll just differentiate this one too. Differentiate this one, power down. So power down, that's going to give us power down 2 times 3, which gives you 6. Power minus 1, which is going to give us 2 minus 1 give you 1. Plus, now power down here, so that's going to give you 4. Anytime I differentiate the number, that's 4. Power down will give you 4. 1 minus 1 give you this one. Is that okay? What if you have a question like that's of, let's say 4y is equal to 4x cubed minus, let's say, 3x squared plus 5 over what? S squared. I have to differentiate this one. I'll do one by one. So here, y here is equal to, so we know very well that this particular one, we know very well. So here, power down. So the power down, that's the power down here, power down. Then I'm having 4x, power minus 1. 3 minus 1 will give what? 2, right? Good. Then here to power down. So power down is going to give us minus, so we are going to get minus 2, they have 3x. 2 minus 1 is going to give you what? 1, right? Then this one, make it linear. This thing seems like what? This is like to differentiate it. So first of all, we could have even made it linear before we start. Let me make it that way for you so you get it. So you could even make it linear before we even start. So this can also be written as y equals what? 4x cubed minus 3s. I just start differentiating it here. And this one we can rewrite it linear because it's the denominator here. It can be written as what? Plus what? 5x minus 2. I hope you get it. It's not linear, so you can now start differentiating it. So this one y here, so I'm going to find dy dx. So dy dx now, we know power down, so power down, that's 3 times 4, 12. Power minus 1, that is x, that's going to x squared. Power down is going to give you minus 2 times, it's going to give you minus 6. 2 minus 1 give you what? X. Power down here is going to give you minus 10x. Then minus 2 give you minus 3. So that's it. Or we can write this one as well. This is correct. We can, this negative, you can take it back to the denominator. So we are going to get 12x squared minus what? 6x minus 10 what? Over what? X cubed. And that's the answer. So we are looking at the rule. Power down, power minus 1. Okay, so let's look at this question where we have to differentiate this one. What's going to happen is that here, look at it. It's also very simple. First of all, make sure you make it linear before you start. This is the denominator here. So what you're going to do that, separate this one by one. Is that okay? So you're going to have x power 5 divided by what? X power 4 plus x squared over what? X power 4. So minus what? 2 over what? X power 4. Still make it linear before you start your differentiation. I haven't started my differentiation yet. So this is going to, if you divide this one, I'm going to get what? It's going to give you x plus, this is going to give you what? S squared, and this one, s will cancel, 2 of the s will cancel this, so I'm going to get 1 over what? S squared, right? Then this is going to give you minus 2 over what? X power 4. Still, let me make it linear because of the denominator here. So I'm going to have x, then this is going to give what? Plus what? X raised to the power minus 2, I put this one, I'm going to give you minus 2, x raised to the power minus 4. So now it's linear, now we cannot find dy dx. To find dy dx now, it's a power down, so power down here, 1. So because there's a variable here, no power, the power is positive 1, so there's going to be 0. So it's going to give you 0 here, right? Because the power down, so if this power down, power 1 down, 1 minus 1 going to give power 0, so that's 1. We are going to have 1. Okay, what we got in it. Let me do it so that I get to 5. This is going to be power down, so power here is 1, so 1. Then x, 1 minus 1 gives you 0 here, right? Then this one power down minus 2. Then this will give you x minus 2 minus 1 gives minus 3. And this one power down minus 2 minus 4, right? Then x here will be what? Minus 4, power minus 1, minus 4 minus 1 gives minus 5. So now we can write this one as what? 1. And this will give you minus 2, x to the power minus 3. This will give you 8 x to the power minus 5. So you can rewrite this one in denominator. We have 1 minus 2 over what? This one. Take this one back to the denominator. X minus x 3 plus what? 8 here. We're going to have x. Take this one to the denominator. I'm going to do x power 5. This is correct, and we can rewrite this one. And that. Thank you for following this one. In the next video, we will be looking at how to find that of using the product, the differentiation of the products and quotient, and we'll look at the chain rule as well. So kindly subscribe if you have not, and let's keep learning and make a brighter future at the end. Alright, before I even give you an assignment, let's say you have a question like y equals to 5 square root x. As I told you, first of all, make this one exponent. So I'm going to have y equals to what? 5. Exponent here is going to give you half. Now that I have an exponent, I cannot differentiate. So I'm going to have dy dx to give you power down. So that's going to give you power down. Half times this is going to give 5 over 2, right? And this is going to give you x minus half. I told you can rewrite this one because the negative here, you can write in the denominator form. So this answer is the same as 5 over 2 here. This is going to give you 1 over what? Square root of what? X. Is that okay? Square root of x, because half is same as square root. So I'm going to get 5. After this one, give you 5 over what? 2 square root of what? X. That's what dy dx. So anytime you have a question like this, make sure you simplify before you start differentiating. You start differentiating when it's not simplified. Okay, so thank you for following to this time. As I told you earlier on, we'll look at the chain rule, the product rule, and we start to differentiate it. Then we'll move on to application of differentiation. Kindly subscribe. Let's keep building this channel together. Let's keep learning as well. Thank you so much. Alright, so try and solve these questions. Okay, differentiate with respect to x. Y equal to 4x cubed minus 3x squared plus 5 over x squared. Then the rest as well. Yes, you know question 5, you have to simplify before you differentiate. The same thing. So don't forget, power down, power minus 1. Thank you so much for following to this time. Have a nice time.